Hello and welcome to this next video in the Dell Storage Technical Videos Library. This is going to be covering the benefits of VDI and Dell EMC Storage Center arrays. My name is Damon Zalesky. I'm in the Storage Applications Engineering team. Here's a list of the topics we'll be covering today. During today's presentation, we will not cover all of the features available in a storage center array, as that would take too long in one slide deck. What I will do is cover the highlights. The speed from spinning drives to all flash drives, the flexibility of mix and match hardware and how we can connect to multiple environments or multiple types of servers, multiple operating systems all within one platform. Ease of use will cover how we automate a lot of the processes and we can make it much easier to manage a large number of disks. From a maintenance perspective, how many processes are automated or can be set to run automated on a scheduled basis to reduce the amount of time spent actually managing the platform. I'll also cover how the reporting works and the types of things you can report on, along with notifications. So in the reporting, we have the ability to report on most active volumes, most full volumes, volume growth, all the typical features you would expect. We also have the ability to set thresholds based on some of those key items. So you can say, I want to get notified when a volume is filling at above a certain rate, or when it hits a certain threshold of 10 terabytes or 20 terabytes of storage. Or I can say when a volume becomes too active. So I want to know if a volume has suddenly become very, very active. I can set a threshold that will warn me before I have a problem with performance with the system. In terms of density, it has to do with the density of features as well as hardware. Because we support a large number of drives in a small footprint, we also support a large number of features in a small footprint. Multiple protocol access, we can do multiple types of interfaces all within one platform. So the product itself is also very feature dense as well as being very hardware dense. I'll start by covering one of the primary benefits that VDI environments have on storage center array, and that's the ability to run an all-flash array. Unlike typical all-flash arrays, though, it doesn't have to stay all-flash, and it doesn't have to use a single tier. It can become a hybrid array, or it can combine multiple types of solid-state drives. Today we use write-intensive and read-intensive drives in various mixes depending on the platform requirements. So we can use write-intensive drives in a very high write environment. We don't have to worry about drive wear leveling, because the drives will be guaranteed for 5 years of full duty. We can mix read-intensive drives in to get a much lower cost per terabyte for environments that want low latency for reads, but don't necessarily have to do a heavy number of writes. VDI environments tend to be very heavy on the writes, but in some scenarios we can supplement the write load with read-intensive drives to expand for capacity for file shares, for user profiles, and for other types of data that don't necessarily go through a heavy write cycle. By supplementing with these large capacity read-intensive drives, we can gain the same latency characteristics of the write-intensive drives for read data, but by putting the data in the most appropriate location, something we call fluid data, we can make sure the data is always available at the best performance and the best cost per terabyte. We also have the ability to insert spinning drives in any of our platforms to gain large capacity when a lot of data needs to be stored that doesn't necessarily need low latency, but needs large capacity at a low cost per terabyte. We have two platforms, SC280 and SC480, which only differ in the speed of the SAS, which provide a large number of 7K spinning drives into the mix for large file shares, for large redirected user profile shares, for anything that needs very large capacity but doesn't need extreme performance. This way it keeps the cost of the platform down while still providing the ability to get into the hundreds of terabytes or even the petabyte range on some of our platforms. Our storage center arrays also have great flexibility. We have the ability to mix protocols in a single platform. We can do a mix of iSCSI, Fiber Channel, and FCOE in some of our higher-end platforms. Our lower-end platforms come with a single interface type, which would be iSCSI or Fiber Channel, but as you move up the food chain, we can add multiple interface types into a single platform. This gives us the ability to talk to iSCSI to some devices or Fiber Channel to others in the same platform and provide volumes to both platforms over those same protocols. We also have the ability to, for example, provide volumes over Fiber Channel, but do replication over iSCSI. We also have flexibility in drive types, in that we can do spinning and solid state in the same platform. We can also do self-encrypting drives if required. In a VDI environment, they're typically not that common because self-encryption applies to very critical data or very sensitive data that may have governance requirements wrapped around it. Because VDI environments are typically virtual machines, the data is typically stored externally, We don't normally put that same data in the same environment, but we can create separate volumes or a separate disk pool of self-encrypting drives for that sensitive data. So we can put it all in one platform. The majority of the storage center arrays we sell today are sold into mixed-use environments where they're not just a VDI platform. They're also a SQL platform or an Oracle platform or file shares or other things mixed into them. So the ability to support multiple isolated disk folders does have some benefit if data does need to be encrypted. We also have very flexible replication built in. A replication allows us to replicate over any protocol that is available to a single or multiple targets. The replication can also be bidirectional in that one array can partner with another array and they can mirror each other's volumes back and forth. That replication can be independent of the protocol of the source volume. So if the source volume is a fiber channel volume mapped to an ESX host or an Oracle host, we can replicate over iSCSI or any other available protocol without taking into account what the source volume was mapped to. This is very important for being able to recover data very quickly and very easily. So if a volume is mapped to a specific ESX host and you want to recover a single file out of a user's VM, you could map that volume to any system available to the array, whether it be over the same protocol or a different protocol, and recover files very quickly and very easily. We can do it based off a snapshot, or if it's in a DR site, we can take a DR volume, spin up a copy of the data without actually copying the data because we call it a view volume. So we can look at the data at a point in time and recover a single file without having to make a second copy of the volume. So it's a very quick and easy way to recover data. Our data reduction encompasses both compression and deduplication of data. We find that in some cases it's more efficient to deduplicate the data rather than compress it. In some cases it's more efficient to compress it. We analyze the data and decide what is the most effective method for storing the data, and we can apply either or both to a single volume or to all volumes within an array. This is done on a per volume basis if you to choose whether or not it applies. In VDI environments where they're typically linked clones, we can see a 1.5 to 2 to 1 compression ratio still because of the mirrored volumes, but on the individual VMs themselves, the compression ratio or dedupe ratio will be fairly low because the data is very distinct per VM. That's kind of the nature of a linked clone. The actual change data is what gets stored in the individual VMs, and that is typically not easy to compress or deduplicate. But we can deduplicate the source images, any file data, any user profile data, any additional volumes that are stored on the array. Live volume lets us take a volume and replicate it to another array real time, and then actually swing the mappings over live. That's what we call it, live volume. This gives you the ability to literally slide volumes sideways between arrays without taking them offline. So if you have a catalog of machines or a desktop pool of machines, you can literally move the volume those machines live on without taking them down. This means you can do storage array maintenance without affecting users. You can literally move volume sideways, take an array offline, do maintenance, bring it back online, whether it be changing hardware, be changing power, or moving between racks. We give the ability to do that without taking an outage, which increases your uptime dramatically. This can also be done for the infrastructure volume, such as your domain controllers, your DNS servers, your SQL servers, your connection servers. All the other pieces in the environment can be moved around at will without taking the outage. This is done via our replication mechanism. And we call that out because it means that the data can be synchronized real time. We can use synchronous replication to make this happen. Or data can be mirrored in an asynchronous fashion, where it be replicated as quickly as possible without impacting performance and without having to wait for an acknowledgement on the remote end that the data has been mirrored. This allows best performance and the data to be replicated to another array, whether the same site or offsite, without impacting performance of the system. The ability to grow without downtimes is also extremely important in VDI environments. Because they tend to grow fairly quickly once they come online, the ability to add hardware for more performance, more capacity, more connectivity, or to upgrade controllers without taking downtime is a key feature of the Storage Center platform. All Storage Center products have the ability to add capacity without downtime. You simply add the new enclosures or just add new drives to existing enclosures that are not completely full, and the system will prompt you how you would like to manage those drives. Would you like to add them to an existing disk folder or create a new disk folder? In the case of SCV2000, they're added to a single pool and single tier of disk. On the 4000 and up series, you have the ability to create multiple disk folders if you wish to carve the disks out into distinct disk types. The majority of our customers actually run a single pool of disk. Since in the Storage Center, all data uses the pool, whether it be live volume data, whether it be snapshots, all that data is stored in the same pool, so any capacity that's added is available to all features on that platform. Storage Center products track data access patterns of given volumes, so we automatically know how active a volume it is, the read-write ratio, how often it's in single pages written and rewritten, so we put the pages where they belong. So the performance is always going to be at its peak because the pages will always be in the correct location. All this happens in the background. There's automated processes that watch how data is being used. For example, in a VDI environment where there's boot volumes that get hit very heavily, those will always stay in the fastest performing tier of disk. We'll restripe it to make it more efficient for storage, but without impacting performance. So in an all-flash array, all the tiers of disk are identical. In a spinning or hybrid environment, the spinning drives would never be used for boot volume unless you specifically tell it to, because they are extremely active volumes. But user profile data, which can become very stale, requires a lot of capacity, will get moved down to lower performing tiers of disk to free up the performance tiers for boot volumes, for temp files, for the type of data that gets hit very often. We also have the ability to add adapters on the fly. So you can change protocols, Fiber Channel, iSCSI, FCOE, or SAS in the case of SCV2000 for front end, while the SC7 and 9000 series can support both Fiber Channel and iSCSI in the same platform. So it gives you a lot of flexibility in terms of how you connect the environment, and you can use one path for volume mapping and another for replication, or all paths can be used for all functions. We don't limit what happens on a path. As long as it's connected, you will apply any of the features you wish to that interface. Controller upgrades are also fairly straightforward. In some of our systems, such as SCV2000, where it's a little bit more restricted, we do allow you to migrate data off of it. On some of the higher end platforms, you can actually upgrade individual controller heads on the fly. This all depends on the configuration of the environment, but we do have a path to migrate from one chassis to another without taking your data offline. Our management is very low effort in that we have a lot of automated processes built in to take care of things for you. Drive replacements, you will get notified that there's been a drive failure. Then you simply walk over, swap the drive out, plug the new one in, and it'll ask you, would you like to automate rebuild? You can also schedule the rebuild if you would rather. So you don't have to impact performance during the day if you are concerned that it may be a performance impacting swap. We also give the ability to schedule restripes of existing data. So if you add a large number of drives to an environment, you can schedule when those drives get striped in the environment. And from a striping perspective, that only impacts the reads, because the writes can be set to automatically use the new drives, but the reads will then get restriped during a scheduled maintenance window, or it can be set to run automatically. It's still a low priority background task, but you can say, I don't want it to happen until my maintenance window. This ensures that you will not have any performance impact. The hardware management is also very easy. If you swap interfaces, go from an 8 gig to a 16 to a 32 gig fiber channel adapter, or change an iSCSI card, we're prompted with a wizard of what is this new hardware and what do you want us to use it for. So we make it very easy to upgrade the hardware, to add drives, to modify server connectivity. We have a simple interface called Dell Storage Manager that handles all of this for you. And we show you all these functions in a single pane of glass for multiple arrays. So it makes it very easy to manage a large number of storage arrays and multiple changes from a single pane. Live volume is also done from within that same management tool. So if you bring an additional array online, you add it to Dell Storage Manager, you can then move new volumes to it on the fly using live volume. You simply right click on the volume, tell it I want a live volume, what array do you want it to move it to, when do you want it to happen, and it's taken care of for you. This gives the ability to do some rack space management, that you can move volumes around, to take arrays offline, to move them between racks if for whatever reason you need to move physical hardware. Giving the ability to move the volumes without taking an outage gives the ability to do some maintenance that you normally wouldn't be able to do without taking complete outage of environment, because you need to shut an array down completely. We also integrate with all the major operating systems and hypervisors, whether it be Windows with Hyper-V, ESX, Xen Server, KVM, some of the Oracle platforms as well. We have a very wide range of integrations across the operating systems and hypervisors. So it means a VDI environment can run on top of a Xen server, or a Hyper-V server, or an ESX server. And we make it very easy to manage the storage. We have plugins for the VMware frameworks, so within the vSphere interface you can manage your storage, add volumes, recover VMs, recover from snapshots, add and delete, resize volumes, all those types of functionality is built in. We also support the ability to cluster physical or virtual servers in the case of virtual fiber channel on Hyper-V. Our replication and backup happen in the background. The operating system doesn't have to be aware of it, so you can replicate volumes to remote sites for DR without having to involve the operating system. In the case of VMware, we also have SRM integration, so we can do a lot more in terms of integration with the VMware platforms. This is because of the framework that they have provided to allow storage integrations with their products. Snapshots are not limited to source device in that when a snapshot of a volume is taken, that volume snapshot can be turned into a view volume and presented to any system that has a server object on the storage array. So if you want to recover data from a volume that was mapped to an ESX box, as long as you have the proper recovery tools, you could map that volume to anything in the environment. So you could do over an iSCSI connection to a desktop or to a remote ESX server. Or you could take an ESX volume, present it up to another platform that can read the data and actually extract the data out. So this gives a lot of flexibility in recovering data when the source server cannot be taken offline, or you don't want to present additional volumes to that source server for whatever reason during production hours. We also have real-time health monitoring in our Dell Storage Manager product. It's also performance monitoring, so we can watch an array real-time and see where the data is coming from, which interfaces have the most load, which volumes are the hottest, which servers are generating the most traffic. We can see real-time latency of individual connections, individual volumes, individual disks, and all this data is stored into a database, which so can be queried later. We also have functionality built in, if you configure it and allow it, to phone home the data so our Copilot team can assist you in performance, troubleshooting, scalability, or advise you in terms of hardware upgrades. So it will upload performance and health data to our servers that we can analyze, we can report on. We can do things like version upgrade notifications. We set rules that your system will upgrade when you allow it to or when you tell it to. So we can track the health of your system, and it makes it much easier for us to diagnose what's going on. We can see when performance levels changed, when suddenly volume started growing, snapshots disappeared, volume mappings went down. We can see all this in a historical. You can report it on yourself, and our Copilot guys can also take a look at it. Our threshold alerting allows you to set thresholds that trigger events. So if a volume grows past a certain point or suddenly starts generating a lot of IOPS, you can say, if a volume generates more than 10,000 IOPS for 5 minutes, notify me because something's wrong. Or if a server suddenly starts generating more than 30 or 40, 50,000 IOPS, notify me that something's going on. Or if I see that a volume has grown suddenly from 50 gigabytes to 500 gigabytes of stored data, notify me because something has changed. These also in a way relate to QoS in that we can prevent a single volume from consuming an entire system. By threshold alerting, you can warn yourself. By QoS, you can throttle it. So there are two different sides of the same coin. This concludes the presentation today. If you have more questions, please contact your Dell sales rep and we can schedule a demo or we can answer any questions that you would like. Thank you.